It's important to determine the accuracy of your AI outputs, particularly if you are using a black box model, because the outputs are all you have to catch biases in the system. It's super important that these AI systems give reliable results and to know what their limitations are. There are a few methods you can use to check. Knowing how to actually apply these methods is out of scope of this course, but I do want to make you aware of a few methods that you can use. We'll cover ground truth data comparisons with cross-validation and performance metrics with the confusion matrix. Ground truth data is the foundation for training and evaluating machine learning models, especially in supervised learning tasks. It essentially acts as the ultimate source of truth for the model to learn from. Basically, it's the labeled data you have that is absolutely correct and unambiguous. To train a model, you'll need to split the data into a training set and a testing set. The training data is usually about 80% of the data, and the test set is usually about 20% of the data. But there are also methods to best determine what split to use. Once trained on the training data, you can evaluate the model's performance by inputting the test set without the labels and compare the output result to the labels of the test data to see how accurate it actually was. Now, performance metrics. This depends on the type of AI model you use, but are particularly used for classification tasks like disease detection or spam filtering. Common metrics include accuracy, which is the percent of correct predictions, precision, which is the ratio of true positives to all positive predictions, and recall, which is the ratio of true positives to all actual positives. Okay, I've probably lost you there. Let me explain. In an email filtering, a true positive is the identification of a spam email that is actually spam. A false positive would be the identification of an email as spam that is not spam. A false negative would be an actual spam email that the filter mistakenly classifies as not spam, allowing it to reach your inbox. I won't go into any more detail about accuracy, precision, and ratio because this is not a data science course, but I wanted to make you aware of these metrics should you want to discuss them with your developers. You might want to also research the F1 score, which balances precision and recall. My aim in this course is to make you aware of terms and techniques like these so you know what to further research and you don't look too bewildered in meetings if somebody brings it up. Okay, let's have a look at the confusion matrix and how that can help. Now, don't worry, it's not that confusing. It's just a grid of 4 squares to map your results on and see how it did. A confusion matrix helps us to see how often an AI gets things right and wrong. By using this visualization, businesses can see if their AI systems are good at making accurate predictions or decisions. Let's take the example of spam filtering. A confusion matrix could help you evaluate how accurate the spam filter is. You place the results of your true positives, false negatives, etc. onto the matrix to see how accurate it was. By looking at these outcomes in a confusion matrix, you can see where the AI is excelling and where it's falling short. For example, if there are many false positives sending good emails to the spam box, that is, it might indicate that the AI is overly sensitive in its predictions, leading to missed emails. Knowing where the AI is performing well or poorly is useful in knowing how to improve the model. You can also compare the outputs to different models to see which perform the best. Some of these quadrants might be more important than others. For example, in healthcare, if you are using image data to detect cancer, you certainly don't want any false negatives. That would mean a patient with cancer would be diagnosed as healthy and not needing treatment. You could argue it's better to be weighted to make more false positives than false negatives. It's better to tell a patient that they might have cancer and might need further tests than it is to miss a patient that has cancer and needs treatment. I encourage you to do your own research in AI model testing if you're interested, as there are other methods. This course is about making you aware of different concepts of AI and the high-level plan of what you need to consider when implementing AI in your organization. I hope you found that useful. If you want to research a bit further, I will put some more links in the resources section.